for this session is on how we connect, integrate, and actually automate across systems. In other words, how your data creates value across the ecosystem. And that's where IrisX connectors, integrations, and the automation studio come in. These components are what allow IrisX to connect the dots between your systems and workflows. Concretely, this includes capabilities such as the Trackunit connector. Hey, I will showcase a little bit around that. It's about automation recipes, so really enabling rule-based actions that can be set up in a no-code, low-code environment. It's a variety of APIs, such as GraphQL, time series, rental, and the custom fields API, really giving you the flexibility and access with deep data integration possibilities. And of course, we also have webhooks to instantly trigger workflows the moment something happens in your fleet. To bring this to life, hey, I will walk through two use cases that Laura already mentioned that really highlight how these capabilities come together. So on the one hand, we have smart servicing, automating service workflows based on connectivity data, and then out of contract usage, capturing value through data-driven alerts and attractions. We'll look both from different angles to show the various levels of depth for such solutions, while at the same time understanding how different capabilities can play together to create powerful outcomes. Good. So let's start with smart service as first use case to showcase these capabilities. When we talk about smart servicing, we are really referring to the ability to automatically detect when a machine needs attention based on its actual usage data. It's about turning raw connectivity signals into triggers that drive maintenance actions. Having said that, hey, let's jump into it.
Great. Hey, similar to last time, we are starting out from Trackunit Manager in our Trackunit construction demo account. Let me move again to the IrisX library from where we can both see and access the respective components. Instead of directly jumping into one of those, I'd like to actually spend some short time on the concept around webhooks, as it's unlocking time-sensitive workflows, which is the topic of today. In order to do that, let me navigate to our IrisX documentation and then find webhooks, as the illustration in our documentation is actually quite great for quick understanding. Here we go. If you look at this illustration, you will see two sides, API polling on the left and webhooks on the right. API polling means essentially that the system asks anything new, ? And most of the time the answer is no, not yet. Not only does this create unnecessary latency and load, it also means that at the time of an important event, such as a critical fault of the machine, it could actually take some time until the next API polling that this error is surfaced. Webhooks flip that model around. So instead of the system constantly asking, it just says, please keep me updated. From that moment, in the event that a machine fault code occurs, the server is pushing an update to the system automatically. So instead of pulling data every few minutes or hours, you get an instant notification, enabling to trigger required workflows to mitigate certain events. Why I wanted to show you this quickly is because in IrisX, it allows you to trigger automation workflows the moment an event occurs. So let me show you a little bit of variety of webhooks that are readily available. Here we have an event catalog that includes events around fault codes, service management, alerts, as well as one particular that I will use today, sites asset enter, which is essentially triggered when any machine is entering a site, which could be a project site, dealer yard, or rental depot. So, key takeaway, webhooks turn your integrations from reactive to proactive, enabling time-sensitive processes to run without delay. For example, starting a smart service job as soon as the machine's rental period ends, which we will go into now. Let's put it into action. All right, let's move over into the Automation Studio here in IrisX. The Automation Studio is a visual workspace inside IrisX that is built on Workato, a leading no-code, low-code automation studio platform that allows you to connect triggers, data, and actions, effectively building automation workflows without having to code. I'm here in my own project space, and as you can see, I've got two recipes set up at the moment. One, which is the smart servicing recipe that we will focus on today. When clicking into it, you can already see a certain flow established, something I've pre-built earlier in the interest of time. But hey, don't worry, we will also add a new component live in just a moment. If you look at the very top of this flow, you will see the trigger webhook we talked about earlier, the one that fires whenever an asset enters a site. That's the event that actually kicks off everything downstream. Next, I have already added a filter to narrow down things to a particular asset that I will be using for this demo. I will be moving it around in the background to simulate it leaving and returning to a site. For you to monitor that with me, let me quickly show you that asset in Trackunit Manager. So here it is, my smart servicing demo machine, currently located in Darmstadt, Germany, close to Frankfurt. That's where it's been actually operating under a recent rental deployment. Now, one thing I've also prepared in advance is actually a custom field for this account called Smart Service Required. You can see it's currently empty. Custom fields are another great example of how IrisX extends Trackunit Manager. They let you attach your own data to machines directly through the API, or in this case, automation workflows, which I will get to. But let me get back to our recipe. The first few steps here are just ensuring that the asset and the site are both captured, and that will help us to use both asset data and site information later in the workflow. You will shortly see what I mean with that. Then I have defined a condition. This recipe should only continue when the asset enters a depot. That's because we only want to trigger servicing when machines return to the depot, not every time they move to a project site. But hey, of course, if you have use cases for that, you could totally do that too. After that, there's a step that requests a Python code execution, which generates actually a service report. I will show you that outcome in just a bit, but depending on that report's output, the result says service required true, the automation continues. If it's at false, it stops right there. That's where really the smart aspect of it comes from. So now let's get into the interesting part, enhancing this recipe. What I want to do is actually a couple of new actions that will run when a service is actually required. Specifically, one, I want the automation to populate my custom fields on the asset. And I also wanted to send me an email notification so I'm aware in real time if a service is required. So let's start with the first one. Here I'm adding an activity using the Trackunit connector, which in fact lets me automate actions across Trackunit Manager. Hey, I will look for the custom fields functionalities first to retrieve the existing field definition, and then, as you can see here, to use the create custom field value action, which essentially will populate custom fields with information that I suggest. Here I will reuse the definition ID that we captured earlier, pass in the entity ID of the asset identified in step 1, and actually specify the value I wanted to hold. In this case, I'm typing in just a simple text entry, service needed. Hey, while this is a free text entry, I could also have set up a custom field as a dropdown or datetime or so, and then just specify the respective selections. But for now, I will go ahead and save the recipe temporarily. Next, I will actually add my second activity, sending an email. I'm typing in that it's being addressed to lfr@trackunit.com. And yes, hey, that's me. Feel free to reach out if you got any IrisX questions after the session. For the email content, I'm dynamically pulling in details we've captured earlier in the flow, like the asset name and the type, and maybe combining that with a little bit of a free text. That way, when the email arrives, I can see exactly which machine is in scope. And then I'm adding some more information in the body of the email, such as maybe depot information and the event time, so that I actually know where and when the respective asset was returned to the depot. Good, so while I'm filling out the email body, just bear with me. As you can see, I've now added again the asset type, the model and name, as well as then some site name and the entry as required information. and while I'm also adding a bit of more free text for the sake of it, so that we can actually see and observe how it looks in a sent email later on. With that, I save the recipe again, and we are ready to see how it works in action. So let's go ahead and test out the recipe. As you can see here, it's now waiting for a new trigger event. In this case, it's the asset needing to move back to the rental depot. Just bear with me for just a moment. I will simulate that movement in the background. So programmatically, I'm moving our demo asset away from the depot. Let me quickly show you in the manager as well. As you can see here now, the position is no longer Darmstadt, which it was before, as you have seen. But now I will move it back into Darmstadt, our depot location, and reload the screen. So there we go, back in Darmstadt. And now when I'm moving back into our recipe, up here on the top left, you can see the test ran successfully, which means the trigger fired as expected and the recipe went through end to end. Hey, so far so good. First, let's look actually at the smart service report that was created by the Python step in the workflow. So let me just take a quick second and open that here. So here we go. You can actually see all the machine details such as model, ID, etc. And we can also observe initial rental information around the period it's been used. But right below that is the machinery scorecard. That's the key element that summarizes and then also determines whether a service on the machine is required or not. If we dig a little bit deeper, we can also see the connectivity events the report analyzed. So on the one hand, the movement of the machines that's been highlighted with the up and down movements here. And then on top, indicators for some special event, such as high impact alerts. So whatever happened here is then also responsible for whether a machinery service is required or not. Hey, on top of that, one of my personal favorite parts, the AI generated summary. This uses actually the connectivity data and translates it into a natural language service report, something you could easily send to a technician or depot manager automatically as well. Good. Hey, having seen that, let's check what happened to the custom field next. So I'm switching here to manager and the machine from earlier, and here we go. The smart service required field is now populated with service needed. That means the automation worked, and this custom field can now be used to filter for machines where a service is suggested by our automation, which is pretty awesome, I think. Finally, hey, let's also look at my email inbox. So let me bring up Outlook here in just a second. And here's a new email, machine smart service demo, urgent maintenance required. And then, as expected, it actually shows the assets information. It shows the site that it has entered, as well as the respective time for it too. So the demo gods, it appears, have been kind to us. So imagine this happening automatically across all of your depots, right? Every technician or depot lead receiving this kind of alert, complete with how the machine was used in the field, what to check, when it came back, etc. No need to open dashboards, no manual data checks, just instant insight right when it matters. Hey, we will of course outline some of the other use cases around Automation Studio later, but I would also urge you to think about it from your end. What are some of the automations that actually help your business to be more efficient? Hey, if you want to talk to me, one of our experts, just click the button on top and I'd be personally delighted to have a follow-up conversation. Good. Hey, that wraps up the first part of our demo. Domokos, maybe you can share a bit about what we've seen in the field with customers using this kind of functionality.
Thanks, Leo. Absolutely. Seeing those sort of like workflow automations is super, super exciting technology. But for us, fleet owners, it's all about having machines out there on rent. With smart servicing, rental companies are cutting machine turnaround time by up to 50%, getting assets back on rent days faster. So what we see is instead of manual processes, checking machines, sending mails, phone calls, as we all know it, a regional rental of about 2,000 machine fleet have saved around $100,000 in annual labor cost, using data and AI to drive efficiencies. And it's not only about internal efficiencies, it's also about top line. We estimated with a 5,000 machine fleet specialist rental that they gained more than $1 million by bringing machines on rent faster. So it's not only in the Darmstadt depot, as Leo was sharing it. Also, we have seen it through across specialist and mixed fleet rental companies gaining company-wide internal efficiencies and top-line revenue. So with that, Leo, anything to add from your side?
Hey, thanks, Domokos. And maybe just actually one reflection from a different angle. I actually had recently the chance to be on site with one of our customers who's using some of the smart servicing functionality, and he actually walked me through how he uses it in his daily operations, mainly for us getting some feedback. And what he was telling me is that having access to how the machine had been used before it came back, things like usage patterns, potential abuse indicators, made actually a huge difference to his work. So it helped him really to understand what to look out for. And for him, it wasn't just about saving time. That is obviously one component, but it was also about the confidence and priorities of his immediate followed actions. So the system evidently didn't replace his expertise, but it was rather augmenting it, giving him context to turning him into the informed action required. And I think that's actually really powerful to keep as a perspective in mind, because behind all the automation and also AI for that matter, it's ultimately about empowering the people who make uptime happen.